So I think I told you to do start from question number 26. Okay, there were a few questions. So let's do this. Summer 22 question paper 1, 2. Skeletal formula. What is the total number of stereoisomers, including the one that is shown? So how many total stereo? Stereo ka matlab hai geometric, right? You've got a double bond. If you have a double bond and there are different groups attached on both sides, okay, for example, Cl and H and Cl, you'll have two geometric isomers, which are known as cis and trans. This one is the cis version. So, is this double bond going to make cis and trans isomers? This one?
No.
Okay, it's not going to make cis and trans because the carbon must be bonded to two different groups. Okay. Is this double bond going to make cis and trans? This one?
Yes.
Okay, because there's going to be an H which is not shown, and there's going to be an H which is not shown. This is the trans version. Okay, you got a double bond, H upwards, H downwards. So there's going to be another version where one of the sides will be switched around. Okay, ये जो है ना, this thing will be on the top, and this H will be at the bottom. I mean, these two will be switched around. Clear? Okay, this is making
Yes.
cis. This is making cis and trans. It's going to have.
Yes.
I'd say it's going to have two orientations, three-dimensional geometries. One would be cis, the other one will be trans. So what about this double bond? Is this going to make cis trans?
Yes.
हाँ ठीक है, तो ये भी करेगा cis trans. ठीक है, so it's going to make cis trans. So again, it's going to have, so that's the three double bonds. One of the double bonds is not making cis trans, but the other two are. Is there any other stereoisomer? There are two types of stereoisomers. One is this double bond thing, and the other one cis and trans geometric. The other one is your optical isomer, where you've got a carbon that's bonded to four different groups. That's a chiral carbon atom. It's going to have two three-dimensional geometries. One would be, they would be mirrored versions of each other. So does it have a chiral carbon somewhere?
Yes.
कितने chiral carbons are? This one, I think, is chiral. It's got four different groups attached to it. I mean, एक side पे there's going to be an H, and it's all four sides are different. If you're standing over here, top is different, this side is different, this side is different, the bottom is different. ठीक है, so this is chiral. Clear है? Chiral में क्या होता है? There are two mirror images. This one will have, in three-dimensional geometry, it's going to be two mirrored versions, just like your two hands. This is not going to be chiral because it's got दोनों साइड में एक ही चीज है. ये clear है? Is this clear?
Yes. Yes.
तो अब मुझे बताओ कि what is the total number of stereoisomers that you'll have? You've got one optical, one making optical isomers, one making geometric, one making geometric. So how many different combinations? How many different combinations can you have? 6. ये plus हो सकता है. This could be cis, this could be cis. Then this could be plus, this could be cis, this could be trans. But there could be. So remember, the combinations are going to be 8. 8 combinations होते हैं ये. We did something similar कि कहाँ पे हमारा yes, June, just like organic chemistry, yes. I said we did questions like this. I told you that if you have got n number of items in a molecule that are making geometric or optical isomers, then the number of isomers are going to be 2 to the power n. ठीक है, यहाँ पे ना I'll show you. Okay, we did something similar and we wrote down naming यहाँ पे. ठीक है, so I told you if a molecule is making like 3 cistrons, so you're going to have 8 combinations. Is that clear? Okay, the first one is cis, the second one is cis, third one is cis. First cis, and this one could be trans. So is this clear?
Yes.
और इसके अंदर मैंने कहा था कि you can include ये 2 पर n वाली बात में you can also include optical isomers. इधर लिख भी लेते हैं, ठीक है. So that so including the double bonds also add the chiral centers to it. Achha, so this one is going to be 8. Can't get paper. Achha, next one is we've got this molecule. And he's saying the molecular formula of CH3 can be represented as an anion, a cation, and a free radical. Species with the molecular formula CH3 can act as an electrophile, a free radical, and a nucleophile depending on the number of outer shell electrons at the central carbon atom. How many outer shell electrons on the central carbon atom must be present for CH3 to act in these different ways? So this is what a normal CH3 looks like. Okay, carbon has, remember, how many electrons? 4 electrons, right? So a normal CH3, one of the electrons is going to be unpaired. So if you've got unpaired electrons, what is it? Is it a free radical, an electrophile, or a nucleophile?
A free radical.
ठीक है, it's a free radical. Unpaired electrons वाली चीज जो होती है ना, that's a free radical. So it's got 7 electrons. So it's either going to be this one. अच्छा, फिर if it's acting as, let's say, a nucleophile, so who gets attracted to a nucleophile? A positive ion or a negative ion?
Negative.
Sorry, if it is a nucleophile, तो हाँ ठीक है, तो न्यूक्लियस के साथ
Then
कौन,
it will be
हाँ, तो नेगेटिव न्यूक्लियोफाइल, मतलब खुद वो न्यूक्लियोफाइल है, यानी इट्स न्यूक्लियस लविंग और पॉजिटिव चार्ज लविंग, so it must be negatively charged, right? So how do you make it negatively charged? Add another electron, now it's going to become CH3 minus 1, right? So this CH3 will actually act as a nucleophile because it's going to have these extra electrons, 2 pairs of electrons that it can donate to someone. Is that clear?
जी sir. Clear.
So that's going to be 8. And if it's an electrophile, that means it's attracted to electrons, so it must be a positive ion. So वो जो एक इलेक्ट्रॉन था ना, वो भी चला जाएगा, and it's going to be positively charged. It will be electron deficient. It will be exciting a pair of electrons from somewhere. So now it will be attracted to electrons. So इसलिए it's going to act as an electrophile. So it's going to be 6 electrons. So the answer is going to be A, right? Clear question ये वाला? और ये तो हम कर चुके थे पहले. So फिर ये पेपर के organic question, this one we finished that. अब ये करना है PDF का PDF. अच्छा फिर से वही खुल गया. Where's summer 22? अच्छा इसमें summer 22 question paper. अच्छा, so organic questions. So bromine reacts with butane in the presence of ultraviolet light to form bromobutane. 2 structural isomers with the molecular formula C4H9Br are produced during this reaction. Draw the 2 structural formulas and state the systematic name of each one of them. So you got butane with one bromine attached to it. So that bromine could either be at the end or that bromine could be on the second position. और उससे क्या है कि it draws two structural formulas. So structure means you have to show the structure as well. So you can draw a fully displayed version, although he did not ask for it. But I guess that would be the safer option. So here I've drawn the fully displayed version. And this one, अच्छा क्या नाम क्या इनके? What would you call them?
First one is chained.
क्या first one?
Chained होगा ना?
नहीं
Chained
नहीं,
actually.
name वो molecule का नाम पूछ रहा है.
Oh,
The systematic name. What's the name of this molecule?
one bromobutane.
Okay, this is 1-bromobutane. That one is 2-bromobutane. फिर वो क्या है? Identify the type of structural isomerism shown. So what is the type? Up now the question is, what is the type of structural isomerism that's shown over here?
So पहले वाला chain.
नहीं,
Positional.
positional like chain तो change नहीं हुई. Chain is exactly the same. The only thing that has changed is the position of the BR. ठीक है, so this
Okay,
is
sir. हाँ. Okay.
so this is position. There's an anesthetic. Identify the chiral center in. So which one is chiral? Left wala, right wala?
Right.
Because this one is chiral with a star. When halothane reacts with ultraviolet light, homolytic fission occurs and the CBr bond is broken. Construct an equation to show. So the CBr bond gets broken. This one over here. So construct an equation. So आपके पास क्या है? You got CF3, and then you have CH, Cl, and Br, right? So the Br is going to break. So it's going to become CF3 and CH, Cl, and the Br gets broken. And homolytic fission is, so it's forming a radical. And the carbon would also become a radical, right? The carbon will have an unpaired electron, and the Br will also have an unpaired electron. ठीक है, ये clear है?
जी sir.
Or so this one is polymerization. We've got draw the monomer of this thing. So monomer is simple that जब भी monomer बनाना ना, when you have an addition polymer, get rid of the like if I draw this, this is a carbon atom, this is a carbon atom, here's another carbon atom. So it's basically one carbon, two carbon, then at the top there's a carbon, and at the top there's a Cl, and then there are two continuation bonds over here. There's going to be two H's with this one, and there's going to be one H with this one, there's going to be two H's with this one, right? So this is the molecule, right? So if I want to find the monomer, what I'm going to do is I'm going to get rid of the continuation bond, or जहाँ पे वो continuation bond थी, I'm going to put the double bond back in its place. So that's what my monomer is. Is this clear? This is the monomer of this thing. This is the monomer of this polymer.
जी sir.
So suggest one reason why the disposal of items made from X is difficult. So carbon chains are very stable. So carbon-carbon bond is non-polar. The link is non-polar and stable. It will not attract electrophiles or nucleophiles. ठीक है, इसका वो देख लेते हैं कि market scheme exactly MS22. एक ही mark था लेकिन what is the exact word he's using? इसने क्या वाई में लिखा है? ये तो हो गया था, दिस इज व्हाट वी डिड। व्हाट अबाउट दिस वन, पॉइजनस हार्मफुल इथिलीन मेड व्हेन बर्ड, कॉजेस पूछ रहा था सिर्फ। ठीक है, सो काइंड ऑफ आई मीन सो इधर बेसिकली हमें कंक्लूड करना चाहिए था दैट इट्स नॉन बायोडिग्रेडेबल। वही कंफ्यूजन थी, हम थोड़ा डिटेल में चले गए, हम वी स्टार्टेड आंसरिंग व्हाई इट्स नॉन बायोडिग्रेडेबल। Well, he just wanted to know okay, it's non biodegradable. I think that will be accepted as well. uh, अगला क्वेश्चन, halogenoalkane, ठीक है, दिस इज द रिएक्शन स्कीम फॉर halogenoalkanes। तो halogenoalkanes में क्या रिएक्शन स्कीम होती थी कि यू हैड न्यूक्लियोफिलिक सब्स्टिट्यूशन इक्वल जाए, एक सेकेंड। अच्छा, halogenoalkanes में ना यू हैड मैक्सिमम मेरे ख्याल से 4। अच्छा, ये तो भी alkenes है। अच्छा, ये था halogenoalkanes। Halogenoalkanes was add NH3, Cl gets replaced by an amine. Add NaCN, Cl gets replaced by Cn. Add NaOH, Cl gets replaced by OH. SN1, SN2 reactions थे इसके. Plus there was another one which was कि वो eliminate होता था कि NaOH ethanolic डालते थे ना, तो you would remove the halogen and instead you'll get a double bond in its place. So you got all these reactions. So you just have to just simply write I think conditions मांगे. So Br getting replaced by OH, that's going to be NaOH aqueous and reflux. अच्छा, और NH, this is NH3 ethanolic and reflux. And heat with reflux. Eliminate करना, you want to get rid of the halogen, that's going to be NaOH ethanolic and reflux or heat. Plus heat. And he says state the reagents and conditions and type of reaction. So that's elimination. This is nucleophilic substitution. This is also nucleophilic substitution. वो elimination था, things got eliminated in that. That's it, ठीक है। ये लेटेस्ट पेपर एक दफा इसकी कंडीशंस और अपनी कंडीशंस जो है ना, वही NH3 ethanolic and heat, NaOH aqueous और NaOH ethanolic and heat, ठीक है वही है। और substitution elimination, that's it. So now the next one is कि what's the next one? A sample of 2-iodopropane reacts under the same conditions as reaction 1 to produce this molecule. Explain why 2-iodopropane reacts at a faster rate. तो वो हमने फास्ट होने की भी स्पीड का हमने पढ़ा था कि when you have halogenoalkanes, तो the reactivity of the halogenoalkanes जो बड़ा होता है ना, that reacts more vigorously, like the bigger halogen, because it's going to make weaker bonds. So it's going to have a lot faster reactions. And the smaller halogen, it's going to make very strong bonds. It's not going to have a very strong reaction. तो वो आपने यहाँ पे लिखना है, ठीक है। और यहाँ पे वही लिखा होगा कि इज वीकर, मतलब बहुत कुछ और लिखा हुआ है तो, और वो उसकी रीजन बता दिया कि why is it weaker, mark number 2, because bigger atoms they have longer bond length, which is why plus their nucleuses are more shielded, so they're not attracting the shared electrons very strongly. अच्छा, इसका कोई बता दे कि यहाँ पे क्या होगा? What's going to happen? How do you get rid of halogen and put CN in its place?
Sir, by nucleophilic substitution.
ठीक है, न्यूक्लियोफिलिक सब्स्टिट्यूशन। ये मैं चार्ट ना, वैसे चार्ट मैंने भेजा है जो सारे रिएक्शंस कहे कि हाँ।
नहीं सर।
एक सेकेंड, ये मैं भेज दूँ। अच्छा, इसके अंदर ना, एक सेकेंड, केमिस्ट्री, यस। अच्छा, ये जो चार्ट है ये बस खोल लेना, समरी है, ठीक है। तो here's the chart. So how do you, all you have to do is, I mean, if you stick to one chart, you'll probably end up memorizing that chart. ठीक है, just get it printed out और उसी के ऊपर ना just stick to one chart. That's it. क्योंकि there's a lot of picture, I mean, picture memory भी एक चीज होती है। मतलब a lot of times what happens is if you stick to just one image, it it gets easier to actually memorize that and recall that as well. कि आपको ना देख के दूर से ही पता लग जाएगा अभी ये जो लाइन है ना, इसका क्या मतलब है, ठीक है। um, so just get this printed out and slowly and surely you'll end up memorizing this. अच्छा, तो क्या करना था? halogen and you want to put CN in its place, it will become a nitrile. ठीक है, so halogenoalkane will turn into, so it's NaCN ethanolic and reflux. That's what your conditions are going to be for that particular, for this reaction over here, कि CN आ गया Br की जगह। अच्छा, what about how do you turn the CN into a carboxylic acid? उसी चार्ट को देखो। What will happen? Once you have a nitrile, how do you turn a CN into a carboxylic acid? It will become acid hydrolysis. You would have to heat it with H2SO4 and reflux. That's it. ठीक है? So that's what's going to happen. This one will be H2SO4 dilute and reflux. ये clear है?
जी सर।
Yes.
और फिर carboxylic acid को वापस अल्कोहल में कैसे convert करते हो? What do you do? So what you do is you take the carboxylic acid, you reduce it with LiLH4. It will become an aldehyde. And that aldehyde will again further get reduced by LiLH4 and it will become an alcohol. So that means you have to add LiAlH4 to it. ठीक है? तो यहाँ पे it's going to be LiAlH4 और वो देख लेते हैं कि खैर से पता नहीं ये मांगा भी था कि नहीं मांगा था। ये मैकेनिज्म कहाँ पे आया था? हमने तो, अच्छा सॉरी, मैकेनिज्म पहले उससे मैकेनिज्म मांगा है। So this is the nucleophilic substitution mechanism. So carbon had these extra electrons. Carbon was positive. Br was slight negative. It's a primary halogenoalkane. So what happens is the nucleophile comes close to it and the Br takes the electrons away. And it becomes Br minus 1. Achha, construct an equation for the reaction in step number 2. So dilute H2SO4. Now he's actually asking for the full equation. So this equation, what happens is that CH3, CH2, CH2, CN. If you heat it with H2SO4, so it's going to turn into a carboxylic acid. And the N will turn into NH4 plus 1. SO4 यहाँ पे most likely it's a spectator ion. So let's just write each plus 1 in its place. और water भी add कर देते हैं. So he's asking for the balance equation. How does the CN turns into a carboxylic acid? But does this look balanced? I don't think it. इसकी देख लेते हैं इसकी बैलेंसिंग उसने किस तरह की हुई है. अच्छा, 2 water molecules, 1 H. ठीक है, then it gets balanced. 2 oxygens, ठीक है, it gets balanced. The only thing is I haven't added. अच्छा, so he's using HCl. मैंने ऊपर H2SO4 यूज किया था, उसने HCl dilute acid. But is this clear?
जी सर.
Step 3 is a reduction reaction. Construct the equation for the reduction. Use H to represent. So step 3 is the reduction, this one. So यहाँ पे I'll just make an equation over here. You'll add, उससे use H as the reducing agent. So what H will do is it will turn into H2. It's going to grab the oxygens and it's going to grab the oxygens and water will be formed. How many oxygens are lost? 2. इसको फिर appropriately balance कर लेना, ठीक है? I mean, you make the equation. 4 H's are needed and it will form water molecules. That's it. और LiLH4 हमने पहले ही कर दिया था, ठीक है? So we are done with this question. बाकी जो next question है, that's I think he says that it contains an alkene and a carboxylic functional group. So if you add Br2, the red brown bromine will get decolorized because it's an alkene. Or दूसरा Na2CO3. If you add Na2CO3 to a carboxylic acid, you'll see effervescence of carbon dioxide gas. और बाकी फिर NM, अच्छा that's not organic. तो ठीक है, इसके organic के क्वेश्चन हमने इस पेपर के कर लिए, ठीक है? क्लियर है ये?
जी सर.
चलो वीकेंड के ऊपर ना ये वाला करना, ये
Yes,
20
sir.
तो वीकेंड का मैं दे रहा हूँ कि वीकेंड पे ना do this one 9701 March 22 question paper 1-2, just the organic questions, and also the paper 2 version as well, ठीक है? चलिए,
Okay,
ओके
sir.
देन, टेक केयर, हाफिज.
Okay. Allah.
Sir,